Welcome back to section 4.5. We are continuing to talk about triangle congruent shortcuts. In the previous lesson, we talked about three shortcuts: side, 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 and side, side, angle. And we found that side, side, angle is not a triangle congruency shortcut. So we're going to take a look at three more here today. We're going to look at angle, side, angle. That's where we have two pairs of congruent angles. Let me circle them here. So obviously those two are congruent, and these two are congruent. So we have two pairs of congruent angles, and the included side. Remember, we defined included angle and included side, yes, in the last lesson. The included side is the side between the two pairs of congruent angles. The second triangle congruent shortcut we're going to look at is side, angle, angle. So we have a pair of congruent sides, and then we have two pairs of congruent angles. But the difference here is it's not an included side, right? That side right there is not between the two pairs of congruent angles. And then finally, we're going to take a look at angle, angle, angle. So if all three angles in one triangle are congruent to all three angles in another triangle, does that mean that the triangles are congruent? So let's get at it. So we're going to do some constructions again, just like in the last lesson. And I know this is a little bit tedious, maybe a little bit time-consuming, but I think it's worth doing this way because it's a good review of constructions as well. So I am being given side MT, angle M, and angle T, and I need to construct a triangle. And just like in the last lesson, the question is going to be, when I construct that triangle, is that the only triangle that can be constructed? If it is, then I know that this is a triangle congruency shortcut. If it's not the only triangle, then I know that it is not a triangle congruency shortcut. So let's go to it. Start with a ray. And on this ray, I am going to duplicate angle M. So I pull out my compass. I bring my compass, let's see, I want to flip it. Oh. I want to flip this over, bring this up. Actually, I got to rotate it around here. Flip that over. Put my compass on vertex M. Slide it out to the arc. That looks about as good as I'm going to get with this software. So then I bring it down here. Flip it over. Put my compass on the end point of the ray. And I'm going to strike that arc. That's the same arc as is on angle M up there. I'm going to come over, and I'm going to measure the opening here. So put my compass on the intersection of the arc and one ray, and then on the arc and the other ray. So there's my opening. Bring my compass down, put my compass on the intersection of the arc and that ray, and then I'm going to strike that arc. So now I know that the second ray of angle M goes right through those intersecting arcs. So I've just duplicated angle M, so I'm going to label that M. All right, so now I'm going to duplicate MT on either one of those rays. I'll do it on the bottom one, but you could do it on either one. So let me measure MT with my compass. Come down here, put that on M, and strike that arc. So there's where T is going to exist. So I'll label this T. So we have MT right there. And now I can duplicate angle T at point T. So I come over here, measure from vertex T out to the arc. Come down here, strike that arc all the way through. Come back up, measure the opening. This could get tricky with my smart board. Let's see. There we go. There we go. That worked out well. come down here, put my compass on point T. Nope, sorry, not on point T. Need to flip this around. I want it on the intersection of the arc and the ray, because I'm looking for where these arcs intersect. So now I know angle T, or the second ray of angle T, will go right through those intersecting arcs. There we go. And what that means is, let's see, they didn't name us a third point, so I guess I can name it what I want. How about, I don't know, U, triangle MTU. Now the question I have to ask myself, is this the only triangle that can be constructed with these two angles and one side, right, where that side is the included side? Could angle U have ended up in any other spot than where it is? And the answer is no. This is the only angle triangle, right? Or this is the only triangle that I can construct. So what I conclude is angle side angle. When I have two pairs of congruent angles and a pair of congruent sides where that side is an included angle, it's between the two, when the side is the included side and it's between the two angles, then this is enough information to conclude the two triangles are congruent. Let's go to investigation 2. So now we're going to investigate side angle angle. And I'm being given one side and two angles, but it's not the included side anymore. So let's construct a triangle. Let's start with KL. No. So I'm going to call that first point K over there, and I'll call this point L. That's K, that's L. Okay, now we can duplicate angle K. So let's swing this around. Slide this out. Strike that same arc. Again, I know this is tedious, but worth doing. That's about as good as I'm going to get with the software. So come over here, put that there, strike that arc. So here comes the other ray of angle K. There it is. Now, the other thing they give me is angle J. Now, I don't know where point J goes because they didn't give me KJ, so I can't just make up point J. What I need to do here is I need to use angle K and angle J that they gave me to find out angle L, and then I can duplicate angle L at point L. And we've actually done some homework problems like this. So you know that a line is 180 degrees, and if we duplicate K and J on the same line, then whatever's left over will be angle L. So let's actually do this, and I'm going to do it since I already duplicated angle K right there. I'm going to work off of that, and we're going to see how this turns out. So I'm going to take my compass, and I'm going to put it, well, I've got to flip it around, put it on J, and measure out to my arc. About as good as I'm going to get. I'm going to take that, I'm going to bring it down here, I'm going to strike that arc. Oh, it's the same as what K was. Then I need to measure the opening. That's about as good as I'm going to get again with the software. And I come down here and I put my compass on that intersection right there, and I strike that arc. So what that means is that this would be angle J right in here. This is angle J. So we know that this was K already. That means that this angle is angle L. And that's what I'm going to duplicate over here at point L. So let's duplicate it. So I take my compass and I come over and I measure from the vertex out to the arc, and put my compass on point L and I strike that arc. Now I measure the opening of the angle. And I put my compass here and I strike the arc. So now the second ray of angle L goes from there right through there. And that means that this is point J. Now let's clean this up a little bit. Okay, I've gotten rid of the parts that allowed me to find angle L, and now we see just the triangle that we've constructed. And this is the only triangle that we could construct. So we can conclude that side angle angle is a congruent shortcut. Okay, we have one more. I know these are some longer videos, but again, I think they're worth doing with the constructions. So I start with a ray, and I'm going to duplicate each of my angles. So I'm going to duplicate R. So I put my compass up here and measure out to the arc. Bring my compass over. It doesn't matter which angle you would duplicate first, second, or third. Does not matter. What you're going to see here, so there I have to measure the opening, right? Looks pretty good. I'm not sure why it's not. Okay, so I struck that arc. Now I can draw in the second ray of angle R. So we know that this is R. That's interesting. All right, so the investigation here didn't give me a length of any side. So I can decide where angle P is going to go. So I'll just randomly pick a point, and I'll call that point P. And now I can duplicate P through there. So I'm going to take my compass. I'm going to come up here. I guess I got to flip it around. I'm going to measure out to the arc. Again, that's as good as I can do with the technology. Put it on P. Strike that arc. Now I'm going to measure the opening of angle P. And I'm going to bring this down here. put my compass on the intersection there, strike that arc, and now I can draw in the second ray of angle P. Now notice, of course, the final point would be Q. So this is Q. And notice that Q looks to be obtuse, as Q looks to be obtuse up here. There's no reason to construct Q because it's now in existence by the construction of R and P. So the question becomes, is this the only triangle that we could construct with these three angles? Now, if you think about this for a little bit, you come to realize that no, it's not the only triangle that we could construct. Let me see if this works. I'm going to outline the triangle that we've constructed. Now I'm going to try to select it. Let me see if this works. I hope. And let's see what happens here. Now ask yourself, have any of those angles changed? Certainly the side lengths are changing, right? Oh, now I kind of screwed it up. But the original triangle, as I drag it out, the side lengths are changing sizes, but the angles are staying the same measure, which means there are an infinite number of triangles that could be constructed with these three angles. So we conclude that angle, angle, angle is not a triangle congruent shortcut. So here's what we have. We have two more triangle congruent shortcuts. Angle, side angle, but not angle, angle, angle.